Okay. All right, so one thing I do want to show really quickly is this, just so everyone has kind of an idea. It'll help you understand what you're seeing in the lab. So in the lab environment, we've got, you see 6 VMs here, but we just have one virtual machine in the lab environment. The virtual machine at the start of the demo is going to be running over there on the left site 1. There's one ESX host in each site or side, and there's an array on each side as well. And the hosts are connected to both storage arrays. So this is what we call a uniform storage access model. So the host in each site is zoned across stretched ISLs or whatever technology the customer's got to stretch their iSCSI or their fiber channel SANs between the two sites. And at the start of the demo, all of these paths are going to have the same priority, and the host is going to use them all the same. And then I'll show you how on the fly we can apply this setting that we call preferred array to turn on this optimized versus non-optimized behavior, and you see that in the demo.
Do the 2 arrays have to be the same level, M20, M50s, or whatever, you know?
Yeah, your question was, do the 2 arrays have to be the same level? So no, they don't. Like at GA, when we first launched support for this, we're going to qualify certain combinations of arrays, but the goal is certainly to allow different arrays to replicate with each other, and it's certainly capable of doing that. We're actually going to support ActiveCluster on some of the 400 series and the M and the X arrays as well, and you can mix and match them.
Related to that question around Purity versions, what's your plan for around because when you do an upgrade, you'll have to upgrade one and then the other, so you'll need at least N+1 compatibility.
Yeah, the plan for Purity version support through upgrades is one minor version. So we're going to release this in 5.0, and you should be able to do synchronous replication between 5.0 and 5.1, or 5.1 and 5.2, or 5.2 and 5.3. So there's just one minor version apart, and that'll allow you to kind of step through the upgrade one site at a time.
Is this a licensable feature, or every customer gets it?
Every customer gets it. We don't do licenses. Our sales guys can't even sell you licenses. There's no SKUs for a license.
Bringing about licensing out of this kind of thing.
No, we're not.
So you get a feature. You get a feature. You get a feature.
So they just have to make sure they've got the proper link between them at that point.
Yeah, and that's part of the reason for the cloud mediator that Tabriz was talking about. So we want to make this feature such that anyone who's got a couple Pure Storage flash arrays can just say, I have a requirement for RPO0, RTO0. I want to just turn this on and get it working. Certainly we want the customers to do some kind of research into what kind of link they have, but you should just be able to spin up ActiveCluster, turn it on. The arrays are going to, by default, use the cloud mediator, and everything will just work, right? So I think no one else is providing that kind of a service where you can just turn on synchronous replication, do it out of the box. You don't have to read a manual. You don't have to get any instructions or anything like that. And I'm going to show you the whole process, like from scratch, basically. Okay, so as we get into the demo, we're just doing a simple demo here. This is iometer running in a virtual machine just so it can draw some nice pretty lines in the UI for you. We're going to try to keep this VM running the entire time through the demo. All right, so let me just talk about the way the lab's set up here a bit. So we have this VMware cluster called ActiveCluster. There's a host 40 and a host 50. And we also have an array 4 and an array 5. So you can think of the 4 side as being on the left of that image I showed you, and the 5 side over here on the right. So site 1 is host 4, array 4. Site 2 on the right-hand side is host 5 and array 5. And you can see the workload here that's running. And this is actually all the customers that are in our ActiveCluster beta are getting a preview of the new 5.0 version of our UI. So this is what the UI is going to look like when Purity 5.0 ships. And what you're going to want to keep an eye on is these numbers right here, reads, writes, and mirrored writes. And you'll kind of see those change throughout the demo. Okay. All right, so what we've got is array 4, or the left array. It's got one volume, and this volume is not in a pod right now. So what you're going to see is like the same steps that a customer would go through if they had an existing environment with an existing volume and they wanted to turn on ActiveCluster. First thing I got to do is connect the 2 arrays. So I'm going to go to Settings, go down here to Connect Arrays. For security, we make you get the connection key from one of the arrays. And I'm going to take that connection key over to the other array. I'm going to say now I want to connect the arrays. So I'm going to put the name the name of the other array. This is actually DNS resolving to the management address of the other array. Replication addresses you can specify, but you don't have to. It'll auto-discover them. And the only thing we added to our connection technology to enable ActiveCluster is this new type of replication, sync replication. So any customer who knows how to turn on asynchronous replication can come in here, connect arrays. They'll see the type. There's a new type now. And I paste the connection key in here, and I'm going to connect the arrays. And this will just take a few seconds.
Can I have arrays connected in both kinds at the, because I might have a pod that I want to be asynchronous and another one that I want to be synchronous. Can I do that?
Yeah, so your question was, can I have one pod that I want to be asynchronous and another one that I want to be synchronous? Yes, you can do that. So we will support multiple connection types. There's reasons why we have different connection types, but our solution actually supports synchronous replication between site 1 and 2, and then asynchronous replication off to a third site for the same data that you're keeping in sync. And we can fail over the source of that asynchronous transfer. So the reason we jumped all the way to an active-active solution is because we're trying to get customers out of the business of having to reconfigure things, because I set up all my policies and I live in site 1, and then if I fail over to site 2, now I have to go and like readjust all my backup policies and my replication policies. I have to tell the target it's going to get data from the other site now. We don't want you to have to do any of that kind of stuff. So once you put something in a pod, it lives on both arrays. Think of it as one instance stretched across 2 arrays. Okay, I don't want to lose place here because then I'll do something dumb. All right, okay, so the arrays are connected for synchronous replication. I'm going to go here to the site on the left. This is my volume that's currently hosting the workload that's running. So I'm going to create a pod. I'm super creative, so I'll call it pod 1. And then I'm going to go to my volume, and I'm going to move this volume into the pod. So this is really kind of like a category change or like a cosmetic move to the volume. So if I go back to volumes, now it's simply called, the name of the volume effectively changes to pod1 : vol 1. So the cool thing about this is, like, if you know how to write an API call to a pure array to make a snapshot of a volume, all you do is use the full name of the volume, and the rest of the syntax of the command is exactly the same. So there's no real change in management for how do you manage things inside a pod. You don't really specify the pod name. You're still doing all your management of volume objects, and you prepend the name there. Okay, so we got a volume. It's in a pod now. If I go back to the dashboard for a minute, you can see there was no real interruption of moving the volume into the pod. And now I'm going to turn on ActiveCluster. So let's see, I'm going to go to pods. Here, I'm going to go to that pod. So you can see under arrays, right now the pod only has one array member. I'm going to add the other array. This array knows about FAO5, knows it's supported for synchronous replication because I connected the two with type sync-rep. I'm going to click add. So right now it says that the pod's online on FAO4, offline on FAO5. It's going to start the process of doing that initial transfer. And it's going to, in the background, use the asynchronous replication engine to copy the data from the array on the left to the array on the right. And that works just like the async we have today. So it's all data reduction aware. It's going to maintain dedupe and compression and all of that for this big initial baseline transfer. You can see it's resyncing now, so it's already gone into a resync mode. So if I come over here to like the replication tab, let's see. You can see this spike of asynchronous traffic for getting the first initial baseline done. And I usually use the minute or so that this takes to talk about how our async engine is dedupe aware, but I've already said that. So maybe I'll just answer your question instead.
Real simple question. Let's say I've got a pod for async and a pod for sync, and I want my pod for sync to go over a particular network interface or this or that, and I want my async to use something else because I don't want to be stealing from that. How do you configure those to be different? Can you configure those to be different?
So I couldn't quite hear all your question. One thing I'll say is, like, let me clarify something, and then maybe you could restate your question. So a pod is not really a policy choice between sync and async. The pod is a container. You could essentially use a pod even if you weren't going to do replication. Like you could put different volumes into different pods, and in the future we may peel those off as different tenants and that kind of thing. You could even start doing some of that today. You're still going to use protection groups for asynchronous replication like you do today. So the pod, inside the pod, you would put volumes in there, you could put protection groups in there, and it's a policy on the protection group that's going to define, do I also asynchronously replicate the volumes in this protection group off to a third array? So it's not a matter of choosing between a pod for async or a pod for sync. Right? And then I think, was your question alluding to like different networks for the two types of replication? That's what I thought. Today we're not doing that. At least in the version 1 GA, you will plumb up a replication network, and that'll be the network that's used for sync and async. And that's our plan, at least. All right, so one cool thing that you can see, I don't know if I can zoom this. This is a new feature in the 5.0 beta as well, that you can click and drag and zoom in here. So you can see we did this initial baseline transfer, and then that finished, and now we've picked up synchronous replication, so just kind of picked up. All right, so if I go back to storage, say volumes.
Question before we move on. With that initial synchronization, are you able to throttle that so that it's basically a trickle feed to do that locally?
Yeah, the initial synchronization, our asynchronous engine already has a throttle. So you can throttle the asynchronous portion. And we'll publish some best practices, and we'll probably want customers with limited WAN to squish a certain amount of their WAN to use for async so that the other stuff stays in sync easily. Okay, so the pod's online on both arrays, and what that means is if I come over here now to array 5, I go to volumes, now I can see I have a pod over there. On pod, I can also see that it's in sync from both sides on this array. Now what this means is that I've got a volume on array 5, the array that was in the image on your right-hand side. So I can just go to, I'm on array 5, I can just go to volumes, here's my volume. Right now I don't have any connected hosts. I will show you here that right now, host 40 and host 50 both see just 4 paths. Each array has 4 paths. So right now the hosts are seeing only the paths to the array that would be on your left. And right now they're all optimized paths, active optimized. So what I'm going to do is connect host to this volume. I'm going to go ahead and connect both of these hosts to the volume. And then this is the first time the hosts have been connected to that array, so that does mean I got to come over here and rescan these guys to find those paths. So now I see 8 paths. So, I mean, that's probably, to me, it's like the coolest thing about ActiveCluster is that we're really just, from a host perspective, you cannot tell the difference between the step I just did and adding 4 more paths into one array, right? It looks exactly the same from the host. There's no different. And in fact, what the host is going to start doing now is distributing half of its reads and writes to the left array and the other half of its reads and writes to the right array, because I haven't told it to do anything different yet. So what that looks like on the dashboard is you can see that the orange line represented the local writes before I was in synchronous mirroring, and the purple line represents that I'm doing mirrored writes now between 2 arrays. You can see the reads are falling down. We were doing about 800 megabytes a second of reads. Now we're doing about 400 megabytes a second of reads on this array. And over on this array, we're catching the other half of that workload, the other half of the reads. Now, you wouldn't want this behavior if the arrays were very far apart, right? Because you're going to pay for one round trip of latency to do your reads across the WAN, essentially. So to fix that, we have this thing we call the preferred array. And it's a property of the host, so I can go into a host here, and I can say that host 4 prefers array FAO4, and then I can say host 5 is going to prefer array 5. And then right now, so our goal is actually to make it do that by itself. But the ability to do that by itself is probably not going to be there in version 1. We are going to do something like right now I have to right now I have to make this setting on both arrays at the same time. So I have to say host 4 prefers array 4, and host 5 prefers array 5. So right now in the beta, we have to apply this setting on both arrays independently. But just like I was talking about, having that pod stretched across the 2 arrays, and one of the reasons that we have 2 different connection types is if you connect 2 arrays with the type of synchronous replication, then you're also telling the arrays that we want you to start shipping configuration information between these arrays as well. So the arrays will tell each other about the host they have, tell each other about the host connections they have, tell each other about the preference settings, that kind of stuff. It's just simply that's not turned on yet in the beta. One of the cool things is that you don't have to go to the host and tell it that you made this change. So if I go back to the dashboard now, you can see the reads have just moved back. So anytime we make one of these configuration changes, we tell the SAN about it. We tell the SAN it should use its path differently. You've got some paths with different priorities now. So it'll kind of just self-heal, self-change, move stuff between the 2 arrays. All right, so now I want to show you something really, really cool, and this is why we went all the way to active-active and why we took the time to make a solution that's truly active-active at the volume level. So right now we've got this VM. It's still essentially getting the same performance it was before. So I'm going to move this virtual machine from an ESX host on the left to the ESX host on the right. So I'm going to move it from host 4 to host 5. All right, and that'll actually happen really quickly, and when it does, we'll see the reads leave this site and go to the other site. There they are. So this means you don't have to do any extra steps, right? So if we had built active passive, if the volume that this VM is running in was passive on the other array, then all your IOs would still go to the primary array back in the other site. And the way most other solutions would have you fix that is to now vMotion the VM out of a data store that's active at the wrong site and into a data store that's active at the site you want to run the VM in now. So you have to physically do data moves to get that to happen, and we don't have to do any of that kind of silly stuff. All right, so I'm going to jump right ahead to. So the state we're in now is the virtual machine's running on the right-hand side on the host. It's also running on array 5 on the right-hand side, and we're going to kill that array. I'm going to shut it down. I should have been logged in here. Sorry, was there a question? Okay, I thought I said some other question. Okay. So what I'm going to do first is I'm going to shut down. I'm going to shut down the Purity on the one of the 2 controllers. And as soon as this finishes, I'll quickly switch over to the other controller and do it there as well. So one of the cool things you'll see as part of this demo, and it's the reason why we built flash arrays to work the way they do, is that we lost one controller here. Everything just keeps running. There's no real performance difference between running, and I'm going to do the other controller as well. So this is going to completely take down the Purity software on the array on the right-hand side. And when this happens, we'll see a short pause in I/O when it comes all the way down. This array has died. This array is not showing any I/O yet. It'll take just a few seconds. In most cases in our failover tests, we see that failovers like this happen around 15 or so seconds. There's a short pause in I/O while the arrays realize that they become disconnected. So keep in mind that the array on the left doesn't know that the array on the right went down. We haven't built in any kind of a graceful shutdown, so the array on the right just vanished, and then we have to talk to the mediator and log the fact that we're going to stay up and keep our volumes online, and that's already happened since I've been talking.
Can you quantify short?
Short pause? Yeah, it's and most times we see it around 15 seconds. That's what happens. It's guaranteed to happen within host I/O timeout. So if you've followed our best practices, if you've configured hosts to be connected to the flash array, if the host can survive a failover between two controllers in a single standalone flash array, then it will be able to survive the failover between two storage arrays in ActiveCluster. We're not going to require any configuration changes. And it's a pretty reliable behavior that we have, is that we actually do about, so it's similar to a software upgrade procedure, and we do about 800 or 900 of those a month is the last I heard that we do those live, where we depend on this failover mechanism. But now we're simply just implementing it between two arrays. So what you see is that I've kind of gone into non-mirrored mode, and my writes have moved over to the array on the left. My VM is still running on the host on the right-hand side. And the UI here is also showing me that I'm not doing mirrored writes anymore. So what I want to do now is start Purity software back up on this array. And the array is going to start back up. It's going to renegotiate the connection with the array over on the left. It's going to automatically ask that array to use the async engine to ship any deltas, any changes that occurred while we were out of sync, and it's going to automatically come back online.
So normally with synchronous replication, you would see some sort of delay in the writes that are mirrored. It doesn't seem like there's much of a delay here. Is that because they're so close together?
Yeah, there's a delay. You can actually see we're actually quite in line with our engineering goals. So our engineering goals were to impart no more than 0.3 to 0.5 additional latency just for our synchronous replication engine, an overhead for the engine, plus one round trip between your sites. And there's actually no distance between the arrays in this demo. So you can see we kind of added, compared to where we were when it was just the orange line, we've added somewhere between 300 or 0.3 to 0.5, 300 to 500 microseconds of latency. So that's actually been going very well in our beta. We're like right in line with the engineering goals that we set. Okay, so Purity's online on this one controller. I'm just going to start Purity on the other controller. But we only really need one controller to run, so we might be starting the process of being in sync already. Oh, well, I sort of missed it. I wanted to show you guys this here saying resyncing. I didn't switch to it fast enough. So we've already resynced and we're back online on both sides. And you can also see that the reads have left this site and went back to the other site, which I have to log into. So when the array comes back online, we're going to automatically tell the host that the array is back online. So the workload will move automatically from the array on the left back to the array on the right. So you can see that here. So our workload just moves back. So it kind of self-heals. So because the VM, I left the virtual machine running on the host on the right, and the array on the right was the one I took offline, and when it came back, it said, I'm back in sync, I can service writes now, you're supposed to be preferring me, I'm your preferred array. That setting belongs to the host, not to the VM or the volume, which means the workload is just going to follow wherever the virtual machine is. So you actually get this kind of VM level granularity for where your IOs live. So that's the whole demo. I don't know how I did on time. I kind of ignored the clock and monopolized everything. Yeah. So another, you guys should come to the ActiveCluster session that I'm going to be giving. It's Wednesday at 1 o'clock, and I'll talk about a lot of other things. We're also going to be doing live demos just like this one in the Basecamp booth. You can come there. One of the technologies I really didn't touch on is you can essentially see how you can take a pod and stretch it from one array to the other, and then I could essentially just unstretch a pod from the array that I was on to the array that I'm on now. So I can essentially kind of move a pod from array to array, essentially walk it across multiple arrays one at a time. So it's really going to give our customers the ability to balance their workloads. You should talk to the Pure One guys while you're here, because you're going to talk about these things, a project we call internally, like will it fit and load balancing, and do I have room on this array to move a workload from one array to the other? other, and we're building all this analytics in Pure 1 to help you make a decision as to whether or not you should do that move. And then the next step, obviously, is to make it happen automatically, or to just have you say, like, for sure, I want to, yeah, sure, you're telling me I should move the workload. Yeah, I want to move it, just move it. And then in the background, the pod stretches and then unstretches, and you get non-disruptive data migrations between arrays.